This time, rather than a gear review, we've got a three-part lens class all about lenses, starting with the basics. So let's jump right in. Thanks for tuning in today. I'm Larry Becker, and I'm really excited about this three-part class on lenses. Our goal is to help you understand what makes a lens good, what various lens terms mean, what kind of performance you should expect to get from various lenses, and how to get the most of what you have. This video will have a lot of basic terms and lens functions. The second video will cover some more advanced topics and terms, and the third video will be about specialty lenses. The goal here is to help you become more educated as a consumer. To begin, you should know that the lenses we're covering here are specifically for DSLR cameras. There are many types of lenses, but today we're going to focus on the two types that most people know about. Zoom lenses that start out at one focal length and then zoom to change your field of view, and prime or non-zooming lenses that have a fixed focal length. So let's go through the parts of the lens that you see from the outside. Up front is the filter thread. This is where you can screw on a circular filter in front of all the optical components of your lens to modify the light coming in. Next is the lens hood mounting groove. We'll talk about lens hoods in a few minutes. On the main barrel portion of your lens, you'll see a turning ring for adjusting focus. All lenses have focus rings, even if they're autofocus lenses, because there are times that you'll want to turn off the autofocus feature. If you have a zoom lens, you'll find an additional ring for controlling the amount of zoom. Beyond that, a few lenses have another ring for controlling how wide the opening will be to let in light. This will be called the aperture ring. Finally, on the back end of the lens is a series of grooves or fittings that allow the lens to be attached to the camera. These are specific to each camera brand, so you'll need a Canon mount lens for a Canon camera, Nikon for Nikon, and so on. Even if you buy a lens that's not from your camera's manufacturer, like a Zeiss lens or a Sigma or a Tamron lens, you'll need to buy the one that has the lens mount for the kind of camera you have. There's a measurement printed on each lens that tells you the focal length of that lens. The focal length will tell you whether you have a wide field of view so that you can see more of the scene around you, or a narrow field of view that brings distant objects closer. If you have just a single number, like 50 mm, which would be 50 millimeters, then you're looking at a prime lens. If you see two numbers, like 28-300 mm, then you're looking at a zoom lens that has the ability to capture a relatively wide field of view and then zoom to a pretty respectable telephoto distance, and everywhere in between. A few minutes ago, I mentioned that some lenses have an aperture ring that allows you to manually adjust the aperture, or how wide the lens opening is, and therefore how much light hits the sensor in one instant. But whether or not your lens has an aperture ring, all lenses allow some sort of control over lens aperture. Most of us are used to selecting our aperture values using controls on our camera. So essentially the camera is telling the lens how open the aperture should be. In the same way that a zoom range can vary dramatically among lenses, aperture ranges can also vary quite a bit from one lens to another. Aperture values are often referred to as f-stop. So you might hear a conversation like, "What's your aperture setting?" with a reply like, "I've got it set to f2.8. Lower numbers mean a wider opening. So f1.4 is much wider than f22. Something to keep in mind is that if you see a single aperture number printed on a lens, it would be written like 2.8, and then that refers to the widest aperture that particular lens is capable of. But just because there's not an f-stop range printed on the lens, it doesn't mean that the aperture is fixed. It's not. You'll still be able to change the aperture value from f2 to something higher, like f8 or f11, depending on the lens. You might be able to go as small as f22 or f32. And while we're covering terminology, making an aperture smaller to let in less light is called stopping down. When it comes to the aperture of zoom lenses, Some will have a single aperture value printed on them, like f2.8, while others will have an aperture range printed on them. You might see something like f3.5 to f5.6. That means that when the lens is zoomed to the widest position, the aperture can be set as wide as f3.5. And then when you zoom all the way into the maximum zoom of that lens, the widest aperture setting you can get is f5.6. Again, you can always stop down to a smaller aperture, but the aperture values stamped onto the lenses always refer to the maximum opening. As a general rule, it takes more precision to make a good quality lens with a very wide aperture, so you'll see these lenses usually command a higher price. Another general rule is that longer zooms in telephoto lenses simply can't have maximum aperture values like a 50mm portrait lens might have of f1.2 or f1.4 because of the structure of the lens itself. They'd have to be as big around as a dinner plate, and who knows how much they'd weigh. To wrap up our aperture discussion, there are a couple things that I want you to know about. First, very wide apertures allow you to capture images with a very shallow depth of field. That means for something like a portrait taken with a wide aperture, you might have one eye in focus while the other eye is out of focus, the ears are pretty blurry, and then the background is just a smooth wash of colors and zero detail. This can be very pleasing artistically. Another thing is that wide apertures let in more light, so the shutter can remain open for a shorter time and still get enough light to capture an image. That's why photographers often refer to lenses with an f2 or f1.4 aperture as fast glass. With advances in modern lens manufacturing, one of the new enhancements some lenses have is something called image stabilization or vibration reduction. Essentially, lenses are made up of several glass elements inside the lens barrel. It's never just the front and rear piece of glass. And these various elements inside bend and refocus light as it travels through the lens. But inside some lenses, there are glass elements mounted on special mechanisms that move the elements to counteract the effect of minor shaking that comes from being a human and hand-holding your camera. Back when I took photography classes in college in the 80s, my professor said we should never expect to get really sharp images if we were hand-holding shots with shutter speeds slower than 1/60th of a second. But with modern technology, we can hand-hold shots with much slower shutter speeds and still get sharp results. Nikon calls their technology vibration reduction, so you'll see a VR designation on some of their lenses. Canon's is called image stabilization, so you'll see IS on some Canon lenses. Third-party manufacturers don't always follow a particular naming structure for their shake reduction technology, and the reason you won't ever see Sony lenses with VR or IS is because most Sony DSLRs have their image stabilization in the camera body rather than in lenses. We've covered some of the basics and even some of the more advanced concepts when it comes to understanding lenses. Next time, we'll go through some additional concepts like what happens when various kinds of lenses are used on DSLRs with different size sensors. But for now, let's wrap up this first video with something simple, the lens hood. Not all lenses come with a lens hood, but most do. They're generally stored on the lens and facing backwards, and you just turn it around so that they make a shade over the face of your lens. The main reason to use a lens hood is to minimize lens flare. Lens flare can come from several sources, but the most common is a light source that shines into the lens, but which isn't part of your intended image. People usually think of the sun, but it could be any light source that reaches the lens from outside the image area. The lens hood does a good job of knocking out lens flare by blocking light from those other angles. If your lens didn't come with a lens hood, you can almost always find one that you can add to your lens after the fact. In our next lens video, we'll be discussing why certain lenses work better on certain cameras. We'll talk about when a 50mm lens doesn't act like a 50mm lens, and much more. See you next time, and until then, for B&H and Kelby Training, I'm Larry Becker. Thanks for watching.
Whether you're a hobbyist or a professional, B&H has the answers to your questions. Experience a world of technology at our New York City Superstore. Connect with us online or give us a call. Our staff of experts is happy to help.
Scott Kelby here, and welcome to this quick tour of our online training. We have hundreds of online classes for you, covering everything from lighting to landscape photography. From portrait photography to sports, we have classes on wedding, automotive photography, shooting, food, fashion, travel, you name it. The most incredible part of this is the price. You get all of this for just $199 a year, or you can pay monthly for just $24.95. 24-hour a day, 7-day a week access from anywhere in the world. I invite you to join with us today and start learning right now.